I'm Sasha Duba from Wuhan Tanzu, and today I have something special for you. It's a application demo. Will show a real world application leveraging all the tools we have, from starting with the Spring Starter project to build the application, to put it in a container registry, deploy it in the Kubernetes cluster, monitor it and operate it. It shows the whole life cycle of an application. I hope you will like the demo. As I first heard about the story, I was very surprised because it's everywhere in the press and everyone is talking about, and I'm well aware about the importance of this project. We at VMware was very proud to receive a request from the Swiss government to present our proposal to build a development environment and application platform for the upcoming vaccine registration application, and to get the chance to present that to this audience. So, what do we know about the requirements? We already have we have the idea and we have a rough concept about what the application proposes and what it should be covered. We already know the application needs to be secure, because people providing health information during the registration process, and we are sure this information needs to be treated confidential and cannot be shared to third parties in any way. As well as the platform and the application need to be consistent. But whenever we build a new version or make changes on the platform, so the application team needs to be sure that the content is consistent during every instances. And the timing factor is very important, because we already know during the current COVID situation, we have an urgency on that. So we cannot take time for weeks and months to prepare the application and develop the application and prepare the runtime environment. So this needs to be done in a matter of weeks. As well, we have to design the application at scale, because from experience from different countries, in the first hours we expect hundreds of thousands of people to register to the application, and we need to be able to cover that load and scaling down if we don't need it anymore. That we can start with the development process. So we have to provide the application team with developer environment. So they need the tools to write the software. That's the first thing. And they need databases in the back to keep the registration information. They need services as well. We provide you with development tools that helps you ramp up your application project in very short time. In the Windows and .NET world, we have SteelToe that automatically generate you the scripts and application artifact that needed to start. And in the Java world, we are very strong in the Spring framework community. And if we go to the page spring.io, you will find the Spring initializer. And this tool allows you to configure actually the application artifacts and the Maven dependencies, and even generate the POM file of your application, and which includes all the dependency you may need. You can choose between the project type if you are familiar with Maven or Gradle, and in the language you can choose between Java, Kotlin and Groovy. So for our project or use case, we are fine with Maven and with native Java. Then you need to provide the artifact name of your application and the application name. And then you can choose between the packaging format. So in Spring we support an executable jar file. This is pretty neat to start with an application, but you could choose the old-fashioned WAR file, which you deploy in an application server. From the Java, in this case we go with Java 11. So let's find some dependencies. For sure, we need the Spring Boot tools. It contains the actuators that let you trace and monitor the application later on. It will be a web application for sure. And we need messaging. Let's go for Kafka Stream. Kafka Streams allow us to develop reactive applications. Then you hit the generate button here, and you will actually get a zip file with the name of your application and including all the dependencies and the Maven project you need to start with your application. This you can then import in your favorite IDE tool. In my case, I'm using IntelliJ. For this showcase, we're going to use an existing application. It's coming from the spring.io, and it is a Spring demo application called Spring Pet Clinic. It's a pretty neat little application showing the capability of the architecture. To be honest, this has a lot of similarity with the application we are going to build, because it is web-based application depending on microservice architecture and REST API services, so it can scale independently, has a database in the back, and it's already designed to register user. And in our case, it's only about pets, so you can go to find owners of pets. You can add new owners, like here. It takes my address here. Don't show my data or share it in the internet. So you can register already users. So it's actually very close to what we are going to do in the application. To compile an application on the personal computer, that's one story. But to build a productive application in an automated way, that's a completely different story, because it needs to be repeated all the time. And therefore you need tools. And typically for that you need a CI/CD pipeline doing that. In our case, we use Concourse. It's a little blue icon here you see on my screen. And there are different tools out there like Jenkins or Bamboo. You're probably more familiar with it. And you can choose whatever you have in your organization. For this demo showcase, we are going to use Concourse. And we have additionally, so it takes all the steps required of a build application, take it from the version control system from Git, compiles the code, and then we have a system called a Tanzu build service, and that's pretty great software because it comes originally from the Cloud Foundry Foundation, and it helps you to build, compile and build application and create the Docker container out of the artifact, because that's typically not so simple process. In case of Java, you need to make a Maven build of the application, you solve all the dependencies, and then you have to find out the type of application. So it could be an executable Spring application or a Tomcat application you need to deploy in an application server or rigid application services, a Tomcat or WebSphere or EAP. However, this is all covered in the Tanzu build service, and it does that for the most common languages. There's only a few of them: Node.js and Python, .NET and Ruby and Go, and there's so much more. And he builds that in a container images, and he resolves all the required layers, like the Java layers, the application server layer if needed. Even for case of Java, he calculates the memory. And at the end, he builds the Docker container used to deploy it in a Kubernetes platform in a standard and reproducible way. Now, as a real-life scenario, assume our application is already in production and management calls you and says, "Oh my God, we have an emergency. We have an error in the application. We cannot go live. We have to change that immediately. The text here is not accurate. We have on the title page." Okay, challenge accepted. Now let's demonstrate how long it takes to make a change into the production. So we go back in our IDE system. So let's make the change. We are lucky we don't need to adjust the code because actually it's only a property which we have here, message.properties, and we have a little bit to adjust the text here. Thank you for all the contribution. Okay, so we make the change. So we have for sure the code in version control in Git. So we make a commit. And we do useful change messages to be sure. So we have committed the change, and now we need to push it to the version control. Now let's see in the Git repository. Here you see that's my repository, Spring Pet Clinic 1. I'm already here in the file, so you see the old text. And if I update the web browser, yeah, the change already has been made. So we have combined our Git repository with our CI pipeline with Concourse and have created a web hook there. And if you take a look in the pipeline, you see this is Concourse, the dashboard. And you see it's already running, so we have a continuous integration going on. And the first thing is the first chapter is source code. And what we actually are doing here, he's pulling the Git repository. And you see this is the link here underneath. This is the Git repository. We just make the change actually. And so he took the code and then compile and test. That's the next step. So he finally found out it is a Java application here, and he's checking for the dependencies and builds the Maven file. So it's already completed. That's the Maven build actually. So it completed. And now we update the builder image. And this is the part we build actually the Docker container. And therefore, so we have to download the base images. We use an Ubuntu base container image. And then we have to resolve all the dependencies, and that's what's going on right now. So we download a mini Linux operating system, then an image for the right Java version, depending what we have chosen, which Java version. And as it is a Spring Boot application, there's no Tomcat needed. So the system is building now the complete Docker container in a completely automated way. And the fantastic thing of that is it can be automated and reproduced at any time. And all the artifacts, the images, goes in the Harbor registry. I tell you a little bit more about this Harbor registry very shortly. And there we have actually all versions of the image in your application is stored there. And this is treated as a repository, a container repository, and from there you can build the application, the container anytime and scale it. So the Tanzu build service is now compiling the application, makes a Maven build and builds the Docker container as we mentioned before. And anything as an outcome, anything he builds goes in the Harbor container registry, as you can see here. Okay, so, but you may ask, how's about the services? Okay, we mentioned at the very beginning, we need a database in the back. And what happens if we have a database change, even a schema change? So this is from the application. It is very simple to rebuild it, but if you have data and you need to recover it and bring it back, that's a different kind of story. I want to show that as well. And the box underneath, there is Tanzu application catalog. And this is showing here. This is an application catalog called Bitnami. It's a company VMware acquired last year. And these are standardized services we are using. You see .NET Core, Apache, and Cassandra, Tomcat. This is standard packaged application. We give support on it and upgrade it regularly. And for our application use case, I'm using the Pet Clinic DB. That's a MySQL database and deployed from the Tanzu Service catalog. And when we take a closer look, you see that the application, the database has been successfully deployed. And even here's the status information, even the encrypted password. And here I can, through the GUI, I can upgrade the database to the next version, or I can roll back the change. So any modification I did, I can roll it back. And for sure, this can be automated. Now we are starting with the continuous deployment. And as you can see here, the Spring, it's taking from the container registry the Spring Pet Clinic image. This here are all the Docker images, the required layers we need. So we get them directly from the Harbor registry. So we have pulled them from the registry, and we have some configuration stuff from the application, like HTTP proxy coming from the Grid repository, so we don't go into detail like that. We make an event in our monitoring. We talk about that shortly. It's a wavefront, so to recognize that we have made a rebuild. And now we are going to deploy the application to our Kubernetes cluster. And it succeeded now. So let's go back. You see our CI/CD pipeline is getting green. Now let's take a look to our application, and still the old text. So let's make a reload. And you can see we have now successfully have a new text here. As anything is in the container registry now, let's take a closer look to Harbor. Harbor is an open source project from VMware, and it's not only a container registry. In fact, it can as well security scanning of the artifacts you have stored in, and even it allows you to control the container images. As a corporate, you can define which sources you trust. For instance, I want to have the latest and greatest VMware Tomcat version because I trust VMware, and I want to have all the Docker images allowed from Red Hat or IBM. But you can even deny some of the Docker containers. The developer cannot just do what they want, you can control it, what it does. And let's take a closer look to the security scanning. That's our artifact we just deployed into the registry. And you see shocking, it's 547 vulnerabilities, and that's pretty high. The reason for this, to be honest, that's a demo application and it's not maintained regularly for the Spring community, but for us it's a fantastic showcase to show the capabilities of the security scanner in Harbor. So when you take a closer look into that, you get a summary of the vulnerabilities sorted in severity. So you see the criticals and the moderate ones. So when you open the first one, in the description, you see the description, it's a heap buffer overflow, a security thing related to the Google Chrome. And let's pick another one. This is a flaw in the Linux kernel. So it gives you a good overview what's the status of your application if you need to patch some of the images. Now we have put all the components together and the application artifact is deployed in the Harbor registry. What is coming next? We need to deploy the application now. And what couple of next steps are required? So we need our Concourse CI/CD. In this case, we need to configure the continuous deployment part. And let's draft that a little bit. So anything from Harbor needs to be deployed to our Kubernetes grid. As we use Docker container and Kubernetes, so we use a Tanzu Kubernetes script. And this is the latest and greatest in the VMware technology. Tanzu Kubernetes grid is a managed Kubernetes environment running everywhere in cloud. So it's running on Google, it runs on AWS, on Azure, and for sure on on-prem. And on vSphere 7, it's even integrated. So it does the same like you do in VMs today. It additionally can scale up Kubernetes workload at the same time. So in this case, we will not have only one, we have different opportunities. And you can guess, as more and more clusters are deployed, the complexity will be increasing, and it gets harder and harder to get these clusters managed by operations teams, because they have come to different versions. Not every Kubernetes cluster can be updated in the same way, so you have to somehow to treat that. You need management capability. Even they are spread out on-prem and on the different clouds, and therefore we at VMware have a solution called Tanzu Mission Control, which is a hybrid management, multi-cloud management solution for Kubernetes cluster. And if you take a closer look at that, we see all clusters managed currently in our environment, and Tanzu Mission Control has the capability not only to manage Tanzu Kubernetes grid, Kubernetes cluster from us, what we think is the best Kubernetes solution right now, but we even support other vendors, Kubernetes services like OpenShift from Red Hat, or AKS cluster from AWS or Google cluster as well. So all of them you can manage in Tanzu Kubernetes grid. And if you take a little look at that, so just pick a cluster, you get a nice overview. This is, by the way, this cluster we run our demo, by the way. So you see the combined amount of allocated CPUs we have and allocated memory we are using. We got some statistic information here as well. You see the Kubernetes version we have installed as v1.18.6, how much memory CPU we have here. And you can see the nodes of the cluster, what we have deployed. So this cluster has a three controller nodes and has about 6 worker loads, and you see even the size of the loads. What is pretty neat is if you deploy the cluster or manage the cluster with Tanzu Mission Control, and it's a TKG cluster from VMware, you even can update it right away from the tool. So from Tanzu Mission Control, you can just choose a new Kubernetes version and update it right away. So in the last section we have well covered cluster management with Tanzu Mission Control, and now we concentrate a little bit on the monitoring part, which is the same way important. And VMware even here has a great solution with Tanzu observability. And Tanzu observability was originally named was Wavefront a couple of time back, and this is a pretty great application for monitoring insights of an application. And if you take a closer look on it, you see here on the top level you see the average requests and even the peak requests to the application. That's important for monitoring and indication. So how big is the load on the application? So how many requests coming in? On the right hand side, we see the top requests, what people are doing on the web page. So which service are consumed and the most. And on the bottom, the top failed requests you can see as well. So we have here a oops request. To be honest, we only brought that in to show you some errors as well. It's a little bit for the statistics of the application. Then a little bit down you can see the request latency, and that's pretty much important. So when we expect the people registering to the service, then we expect latency goes up, and this is an important information, so how we can tune your application and make it better, scale it up even more. And especially for the application here for Java, in case of Java application, we have garbage collection, we see the heap size of the application, the number of threads, and all of these values are good indication about the application health. Now, as we have the capability to deploy multiple Kubernetes clusters, not just in one location, so on-prem or even in the cloud, so why should we rely to set our application on only a single cluster? So it's actually possible to put parts of the application on different clusters. For instance, the database you keep on-prem because of the performance, and other part of the service like application server you scale on the cloud or maybe on multiple cloud. And therefore we have a pretty neat service called a Tanzu Service Mesh. And as you can see in that example here, our E2E demo application is running in fact on two different clusters. So we have on top, it's running on an EKS cluster. We have the catalog service with the MongoDB backend, and the majority part of the application, rest of the application runs on the on-prem department, and the single services like the shopping service or the load generator service is consuming is communicating with the catalog service. So this is all measured together and with mutual TLS encrypted, so you don't have to do anything, it's done automatically. And actually it's possible to share the workload in different clusters, and if an Azure cloud on AWS is a performance problem or a cost problem, you just scale down the workload there and move it over to the other workload, to the other cloud provider, and increase the settings there. It gives you extremely powerful of managing the cluster. So we have now a finished application. We are ready from starting to the end, and I think we could show you, illustrate you like VMware Tanzu, how we can help you to build a powerful application and with our tools and services underneath. And I hope you like the demo, and if you want to hear about us a little bit more, go to vmware.com/Tanzu. Thank you very much for your time.